Aloha, Richard Halverson here. This is ICS321, and today is March 10th. And let me share my screen, see where we are. 3. All right, so we are supposed to be starting chapter 5 today, but it turns out that there was a whole bunch of these SQL problems here, and I want to get through all the SQL problems because I would say the most important thing that you get out of this class is knowing how to write SQL. Okay, after that, it's maybe making entity relationship diagrams or designing databases, being able to be handy with MySQL, knowing how to create databases and so on. That's pretty straightforward. You can always look that up, but crafting the correct SQL statement is kind of the hard thing. So so I don't mind if I spread that out a little bit. So I'm going to go make sure that that there's nothing important in chapter 4 that we need to cover that we haven't. And then I'm gonna go back and I'm gonna do some more SQL problems, and I'll be sure to put the which SQL problems I do. I'm talking about the programming exercises, the labs in chapter 3. And also there's a couple of assignment sections of assignments that have that too. So hold on here. I'm going to move to a different part of the ship. All right, here we go. All right. Okay, so we finished up last time with lab 315. So that was this lab here. 315 is where we finished. Functions, aggregate functions. Sure. Okay. Yeah, here we're getting into group by and so on. Oh, and these are functions that are provided and select by the SQL. These functions here is what we're talking about, not stored procedures, stored functions. We'll get into that later. But let's take a peek at chapter 4. I just want to make sure okay, this is entity relationship diagrams. Okay, so this is chapter 4 is a pretty important chapter for you to make sure you go through and read. And I probably don't need to waste your time going over this. The book explains it very well. It's not a very difficult concept. The concepts aren't very difficult, and the diagrams, it's easy to diagram it out, and examples are easy to follow because they're experiences that most of us have had. From the entity relationship diagrams, you should be able to derive the tables and the relationships between the tables of your database. So defines these concepts. An entity is a person, place, product, a concept, or an activity. Relationship is a statement about two entities like this. These are two entities. And then attributes are descriptive properties of an entity, like a passenger can have a couple of attributes here, a passenger number and a passenger name. Booking can have a couple of attributes here, booking code, booking cost. And this relationship thing, a passenger holds a booking. Passenger can hold more than one booking, but a booking can only be held by one passenger, that kind of thing. So read through this and make sure you understand this is mostly terminology. All the projects in the company become an entity, right? Okay, so make sure you click through these so you get all the points. It's really sad when people don't people don't realize that all they got to do is click through the things, and instead of getting an A-, they get an A, you know, that kind of things. So there are these things called entity relationship diagrams, which you should learn how to at least read and, you know, understand what they mean. You may end up having to write them someday if you're working in a big software development environment, got a database there. So these are terms which entity relationship diagrams should have. There should be a glossary, sometimes called a data dictionary, referring to the animation above. How is the schedules relationship read? Airline has flights. Flights schedule. Airline flight is scheduled by airline. I think it might be airline schedules flight. Yes. In the direction of the verb. Relationships are read in the direction of the verb. Schedule starts at airline, and so schedule starts at airline, so airline is read first. So anyway, make sure you understand that. Entity relationship modeling. An entity type is a set of things. A relationship type is a statement about the entity types. And the attribute type is a set of values. Okay, so go through this and make sure you understand this. See if there's any kind of challenge activities we can start. So here's a exercise that you go through when you're designing a database. There's a discovery phase, and you determine what all these things are. And so read through this, go through the participation exercises. And make sure you click through these and understand them. Of course, you can just click through them, but you might as well learn it along the way, because it doesn't use up that much more time, and you feel like you got something out of it. Okay, let's see if I can do this. Now, I didn't read this section very closely, but our library system has several branches. Each branch has an address and a unique code. Each book belongs to a particular branch. Each book is assigned a unique barcode number and has a title and a publisher name. Each library member may borrow up to 3 books at a time. To join the library, a member provides an identification number, identification type, and identification type. So what are the entities? I don't know. Well, let's see. I think a member is an entity, and I think a book is an entity. Member borrows book. Library has branch. Book has publisher. No, the book publisher would be an attribute. Okay, so it's either an attribute or an entity. Gee, I'm not sure. I'm gonna check this. All right, the incorrect one is highlighted. Oh, expected book branch member. Okay, so I shouldn't have said library. Oh, the library would be an attribute of the branch, I bet. The database tracks information about books, information about branches, and the data in the database pertains to our library system. Since the database does not track multiple libraries, library is not an entity. Address is an attribute of branch. branch entity, not an entity. Database tracks members. So members is an entity. Okay, well, when we click next here, we get a chance at the same one, and you can step through those. Try to make sure you understand that. Cardinality has to do with whether it's you know, one-to-one, one-to-many, many-to-many kind of thing. You know, an airline can have multiple flights, and according to this, a flight can be held by multiple airlines. Multiple airlines share the same flights. Each flight can be scheduled by multiple airlines, so it's many-to-many. Many flights depart from one airport. A flight departs from just one airport, but an airport can, you know, many flights can depart from an airport, but a particular flight only departs from one airport, and a particular flight only arrives at one airport. You know, an airport just has one address and so on. So that's, you can see these one and many. So we also have this concept of see, I guess we don't has, okay, we has a is a, okay, so we haven't gotten to that yet. Okay, so the relationship maximum is the greatest number of instances of one entity that can relate to a single instance of another entity. A relationship has two maxima, one for each side, and maxima is usually specified as one or many, denoted as a one or an M. And so a department can have many employees, but an employee only works for one department. So employee works in department has a maxima of many and one. Many employees, one department. Occasionally, a relationship maximum is a number greater than one. A maximum can be greater than one. Each employee has at most 3 telephone numbers in a database, and each telephone number belongs to at most one person. All right, so that's make sure you understand these concepts. Click through this, nail that down. And then there's a minimum. It's 0 or 1. So it's the least number of instances one entity can relate to a single instance of another. So a relationship has 2 minima, one for each side. A minima is usually specified as 0 or 1. So it's usually shown afterwards in parentheses, like that. So a passenger holds one booking. A booking has to be held by a passenger. You can't have a booking. You can't have a booking without a passenger, and I guess you can't have a passenger without a booking. A flight. You can't have a booking without a flight. So exactly one. A booking is the minimum of one flight. But a flight can have no bookings. You know, until it has one booking, it has no bookings. A new flight has no bookings. So you got to keep straight. You know, this one refers to how many. What's the minimum this can have of this? So that one is over here, and this having this is the 0 over here. So you got to get that straight in your head. Go through these exercises. So entities have an implicit relationship with their attributes called entity has attribute. This relationship, like any other, has maxima and minima. So make sure you understand that. So let's go through one of these. Each number is assigned to one employee. This is an employee number. So each number is assigned to one employee, and each employee has one number. A passport is unique, since a passport belongs to one employee. So is a employee number. Passport number is plural, since an employee can hold passports from multiple countries. And a name can describe many employees, but each employee just has one name. And each skill can describe many employees, and each employee can have many skills. So so you got to keep track of what goes on the left and what goes on the right. So employee has all these things. These are attributes of the employee. All right, so you can make sure you keep that straight in your head. These minimums can be either optional or not. So an employee has one number. The minimum that an employee has is one number. The minimum passport number that an employee has, this is the it's 0. An employee might not have any password. Employee has to have a name, one name, but an employee may not have a skill, or may be optional. All right, so so when we're designing a database, the relationship and attribute cardinality depends on business rules. And a company assigns employee, it's possible that a company assigns employees to multiple departments and so on. So those are, it's up to the way the company decides to make the rules. It's business rules. And so this explains, depending on the desired level of detail, cardinality does not always appear in the ER diagrams. Usually ER diagrams are drawn with software tools that can automatically show or hide cardinality. Okay, so understand this. Another one of these. Okay, so determine the relationship. Okay, let's see what this is. A registration is for a specific vehicle. Each vehicle has one registration. Determine the relationship maximum. Guess it's this. What's the next one? Each state has many residents. Each person is a resident of one state, I believe. Determine the relationship minimum. Person resides in state. I guess a person, do we say a person has to reside in a state? Are we talking about all? I don't know. Minimum. State doesn't need to have any residents either. I'm gonna just say this and see what happens. It'll tell me why. Okay, the expected 1-to-1. A state must have at least one resident. So really? Oh, okay. I didn't know that. It doesn't say that. So one person. So one on the person side. Each state has to have at least one resident. A person. What happens if all the residents of a state leave? Then is what? It's not a state anymore. A person must be a resident of a state. So one on the state side. Well, what if it's a person that doesn't live in the United States? I mean, it's not clear. So anyway, fortunately, you can just click through this until you get them right. I could put feedback there, but I'm not going to. Independent and dependent entities. Okay, so this is another concept thing. An entity A depends on entity B if instances of A exist only in relation to instances of B. So a task depends on project if all tasks must be part of a project. So if all tasks must be part of a project, that means you can't have a task without a project. You can have a project without I don't know about that. A project must exist before project tasks are created. When a project is deleted, all the project tasks must also be deleted. All right, so the dependent entity depends on another entity called a master entity. Shouldn't be, that's not politically correct. It should be parent entity. The dependent and parent entities are related by a dependency relationship. So, and then there's independent entities. In a university database, students and departments can be created without reference to any other entity. So students can be members of, okay, yeah. So they can be independent entities. Dependents and depend on different meanings, have different meanings in entity relationship and relational models. Okay, so dependency in entity relationship diagrams are what we're talking about here, but dependency in relational models have to do with the state, the zip code can determine the state, so the state depends on the zip code kind of thing. So just keep that in mind. This is called existence dependency, and the other one's called functional dependency. All right, so make sure you understand this. Drag these around. Dependent entity. Dependent exam. And exam belongs to course would be a relationship. And oh, is that wrong? Did I get that wrong? Not right? Oh yeah. Master entity would be, I guess, athletic department. And then these these are master entities. Oh yeah. Oh, master entities, because the course has exams and athletic department has whatever an athletic department is. And so an athletic department is an independent entity. Okay, anyway, and we can reset that and start over. Make sure you understand it. There's different conventions and different terminology here. So you can read this. I happen to like this crow's feet notation, but we see this a lot in this textbook. So and we go through this. Here's this animation shows one subject area from a cloud information model, an industry model for sales fulfillment of databases. You can click through this. The subject areas, party, payment, and then those are all the shipment is all these things. These are the relationships, many. So that this describes the crow's feet, which this describes that. Circle, one, and many. Crow's feet is many. All right, so make sure you understand that. And a real estate company manages several office buildings. Each office building has office suites and meeting rooms. Some but not all meeting rooms are assigned to an office suite. Oh. Select the correct dependency relationship for each entity. Okay, so you can click that and step through that. Let's see. All right, let's keep moving here. Supertype and subtype entities. So we have things like vehicles, but then we can have electric vehicles and gas vehicles, kind of like classes and deriving classes from classes and so on, kind of the same thing. There are these is-a and has-a relationships, more terminology. It's helpful if you click through these. Here we show how similar entities can become, can be sort of collapsed, and you create a super entity type like this. There's subtype, these are, and you have super type and subtype entities instead of having 3 separate entities. Kind of makes sense. And you can also partition attributes. You know, you can have, for example, a credit card type. There are different credit card vendors, and there are different types of credit cards, and each, you know, all the vendors offer all 3 types and so on. So those are separate things. And you can match high-level step names to detailed activity descriptions. You can go through this and make sure you understand that. Each pot has a volume measured in quarts. Each pan has a diameter measured in inches. Each baking dish has a length, width, and a height. Select the correct description of each attribute. Okay, you can, let's see. You only get one chance with this one. I'm going to see what is material is an attribute of a subtype entity. A cooking vessel. You have a cooking vessel. It's made up of material. Each pot measured in quarts. Pan has a diameter measured in inches. Each baking dish has a length. Okay, so there's 3 vessels, and material is an attribute of the supertype entity, because it can be a pot or a pan or a dish, and all this says is each cooking vessel can be made of a particular metal. All right, so I'm going to guess that, and width would be a subtype attribute of a subtype entity, because width only is concerned with baking dishes. So okay, let's see what this is. Oh, great. Okay. All right. So here now that we've defined all that, we have our entity relationship diagram. Then we can select, you know, then it comes time to designing the database from that. And in a big environment, a big, large software development environment, you might do it that way. So it's really good that you understand what they're talking about up there. And maybe you might end up being in a smaller environment. You might end up being tasked with being on the database development team, and you might be able to bring these skills to that. So so here we go through picking out our primary keys, and this talks about how primary keys should be simple, stable, meaningless, and so on, just like we learned before. Implementing independent entities becomes an independent table. We have implementing subtype entities. You know, we have we usually have, well, it looks something like this, where we have a passenger number, and then within that we have table which contains another table which contains, say, the mileage plan member information, and it's got a field in there which connects it back to the passenger. So that's how you would implement that. And so let's see, refer to the runway dependent entity below. So runway depends on an airport. Correct answers may depend on business rules. So airport runway name, airport code, runway name, any numbers, might not be a good primary key because of the 0. There might not be a name. I might not have a name. Let's see. So I'm going to say false. Correct. The runway name indicates 0. It means it's optional. So in a case it wouldn't. And you can't have a null value column to be part of the primary key. Airport code runway number. Yes, I think that is because it has to have at least one. There might be many runways on an airport, but okay, so let's say true. Dependent table primary keys usually contain the primary key of the master table, and in addition, initial column for uniqueness, and that's what this is. Assuming runway numbers are unique, the composite is a unique primary key. Okay, so obviously, so this sort of it's a way of methodically figuring out what these things should be, defining the keys. So let's try this one. Assume the following rules. Each college has a name. Each a college can be renamed. So that doesn't sound like a good primary key, maybe. A college name might include information like state, university, or college, as well as an academic area. More than one college can have the same name. A college name can be long and hard to type. Okay, so let's start this and let's try this one. So we're supposed to say, which of the following properties does the college name attribute have? Is it unique? No, it's not unique because more than one college can have the same name. Is it required? Every college has a name. More than one. Yeah, every college has a name, so I guess it's required. Is it stable? No, it's not stable because it can be renamed. Is it simple? No, it's not simple because it can be long and hard to type. I'm sorry, it's not stable. It is required, it's not stable, it's not simple, and it is not meaningless. So I think this is the only one. Yeah. All right, what's next? Implementing relationships. Okay, these are the foreign key things now. Implementing relationship step converts relationships to keys or tables, depending on the relationship cardinality. See, many to many, you actually have to stick a table in there. If it's one to many or many to one, you can just get by with a foreign key. The foreign key goes in the table on the many side, obviously. If you think about it, wouldn't make sense to put it on the one side. A foreign key refers to the primary key on the one side. So foreign key name is the primary key name with an optional prefix. Prefix is derived from the relationship name and clarifies the meaning of the foreign key. All right, sure, you can do that if you want to. If you don't name them exactly the same, though, then you can't use natural join. So this talks about that. Implementing one-to-one, you can just, it doesn't matter that much which side the link goes in. One-to-one. So, so airport is located at an address. An address does not necessarily have an airport. Right, obviously. So obviously you put the main key in there, and the airport would have the address of the the location address ID. And of course you wouldn't put the airport code in the address because there's going to be zillions of addresses that wouldn't have an airport code. So that's that. Now, when it comes to many-to-many relationships, then we actually have to have a separate table, and that table has got to contain as its primary key. It's going to be a composite of the two sides, one from one side and the other from the other side. So, passenger can have many credit cards on file, and a single card can be issued in the name of many passengers. All right, so depends on the credit card vendor, actually. All right, so click through this, make sure you understand it. Let's do one of these. Let's see, University ID has a campus. Okay, let's start this. All right. In which table should the foreign key be placed? I think the foreign key should be placed in the campus table. Why? Because you wouldn't put the foreign key in the university table, because there could be many campuses, and how many fields you set aside for campuses. No, a campus can only be part of one university. So, and a campus has to be part of the university. So it's best that the foreign key be placed on the campus. What is the name of the foreign key? University ID. Oh boy. Does it say it should be something else up here? Okay, this is a one-to-many like this. I'm just going to see what it says with this answer. I'm going to see what it says. Oh, then are nulls allowed in the foreign key column? No, I would say no. So I'm going to check this. I'm not sure about this. All right, very good. You can do the next two. Implementing attributes. Well, this is the easy stuff. These are just fields. Okay, so attributes can be singular or plural. Each entity instance has at most one singular attribute instance. Each entity instance can have many plural attribute instances. So each entity instance, okay. The implement entity step, entities become tables and attributes become columns. Entities become tables and attributes become columns. Single attributes remain in the initial table, but if yours can be plural, then you put it in a separate table. So, here, for example, okay, let's see what this does. Okay, so we have a flight plural attribute with maximum M. So you can have 3 different meal types. You can have M meals or no meals. So we're gonna create a new table called meal type, which is connected to the flight number. primary key is the composite of the plural attribute meal type and the foreign key flight number. So now a plural attribute with the maximum of 3, you can do just something like this. That's what this is saying. If it's small, you can do it like this. And the advantage of doing it like this is then you don't have to join it with another table, which can slow things down and all kinds of stuff like that. All right, so this is talking about that. Make sure you understand that. Implementing attribute types. So this is where you'd have in the glossary, the data type, varchar, char, are you familiar with that? Those field types, implementing attribute cardinality. You can use unique and you can use not null. Not null, we'll say it's got to be something there. You can say something is a primary key. And so by adding those attributes, not null, unique, not null, by adding those attributes, you can enforce the cardinality. So make sure you know how to do that. This asks you to make sure you know how to do that. And these are the steps. This is how you do in the database design phase. These are the things you do to implement attributes. And oh, what is this now? This is a nice challenge. Let's see what this is. Which properties apply to each attribute? I wonder. The shirt code is unique and required. I think they're all required. Shirt size. Shirt prices, many shirt prices. I'm going to see if this is right. Okay. The incorrect answer is these plural. So I didn't know what that meant. So the answer is, you can have many different shirt sizes, but only one of them for a shirt. You can have many different prices, but only one of them for a shirt. Okay, so you can try it again. All right, normalization. We know about normalization. Boyce Codd, you try to make everything as close to Boyce Codd as you can. This talks about that. So in the original paper, it's normalization meant achieving first normal form, but over time, the term normalization has come to mean in achieving higher normal forms. The highest normal form that you need to achieve to make sure you enforce the redundancy, the absence of redundancy that you want to ensure. So this just goes through all that again. This should be, sometimes you denormalize just to speed things up a little bit. You can do that, make things easier. And match the activity with resulting normal form. Consider denormalizing tables in reporting databases. Eliminate dependencies on column contained within a composite unique column. Non-unique columns. Well, I'm gonna guess. Is this right? And is this right? Is this right? All right. So, okay. Here's this is implement independent entities, Sequila database. You're supposed to do your Sequila database. You're supposed to do this on your Sequila database and then paste the result here. Is that what you're supposed to do? I think that's what you're supposed to do. What time is it? 2:30. Implement a new independent entity phone in the Sequila database. Attributes and relationships are shown in the following diagram. The diagram uses Sequila naming conventions. Create a create table and alter table statements that do that. Step 2 requires adding a foreign key and specify the data types as follows and apply these constraints. And then I guess we're supposed to paste it into here. And we don't need to use our Sequila database. We can use our online database that we have. All right, so I'm going to do that. It would be in Richard H. Go there, and I'm going to just go to /cpanel. I can't remember what my login is. Might be this. So let me see if this is it. I think this is it. Let me go to PHP my admin and see what I had. Do I have a test database someplace? Let's see. I got, oh, look at this, Sequila. Whatever, I'm just gonna use this. Make a new, wait a minute, no. I'm gonna make a new table. I'm gonna make a new database. So I'm doing this. I'm doing 4. I'm just store staff customer. Wait a minute. Do we have store staff customer? Are they here? Store staff customer. Okay, here we go. So I got to put it in here then. I got to create one in here called phone. Okay, so great. So let's look at customer. Get plenty customer. This is the structure. Wow, complicated. All right, so let's see if I can figure this out. I'm going to put this down, close this, close this, close this, and I'm going to put my database. Where is this? Put this maybe here. And I'll put this, I guess, down here. Okay, so I got to go back to PHP my admin. Let's do this right here. Okay, do this. Let's see what I'm doing. All right, I got to create a new table here. Maybe I should do this. Oh, that's not going to work. All right, I'm just going to create a new table down here. I'll just go. Where? Tables. New table. Call it phone. It's going to be this phone. And I'm going to pop that over there. And make this. Make this a little bigger like that. So I'm going to call it phone, and it's going to have 1, 2, 3, 4. Phone. And it's going to have 4 columns. Go. Okay, I'm going to call it phone ID underscore ID. And I'm going to say foreign keys have the same name as reference primary key. That's good. I'm going to have country code. A phone number. And phone type. And implement has a relationships with foreign keys in Sakila customer, staff, and store. Oh, customer has a phone. Store has phone, staff has phone, customer has phone. Okay, so does it say what the phone ID? Phone ID int. Okay, see these are all ints. Int. Phone type is varchar 12. Varchar 12. Varchar 12. Apply these constraints. Not null corresponds to cardinalities and diagrams above. They all need to be something except for type. So this has got to be, this can be null, not null, not null, but this can be null, I guess. Phone type has a data type varchar. Not null constraints correspond to cardinalities above. Foreign key actions are set null for delete rules and cascade for update rules, and specify the suitable column as the phone table primary key. Sure. Well, this should obviously be the primary key here. Phone ID. I guess phone ID is going to be the, yes, must be the primary key. Okay, so let's make this the primary key. Primary. Yes. And let's make this INODB because all the rest of them aren't. I think. Sure that happens. Specify a suitable column. Okay, that I did that. Oh, I gotta set that for the foreign key constraints, and those will be over in the other table. Ooh, yeah. All right. So I'm gonna save this. And I'm going to go over to customer. Okay, I'll go over to store. Oh, customers up here. Structure of customer, what does that look like? Customer ID, store ID, there's no phone ID. So I got to add a phone ID here. Is that what I got to do? That's what I got to do. Ooh, remove the existing phone column. from the Sequila address table. Oh, really? Remove it? All right, sure, I will. I'm gonna make a copy of it though before I remove it. Okay, so I got this customer and I gotta add a, I'm gonna make a copy of these tables, okay? Because I just wanna make sure I can go back to where I was. I'm gonna go structure, customer, and I'm gonna say operations, copy table. I'm gonna say copy it to customer, and I'm gonna put, I'll tell you what, I'm gonna put this. I'm gonna put 4.10. Customer 4.10. No, I'm going to put the date. 2022 0310. That's just the date. Okay, 2022 March 10th. That's today. So I want to make this. So I'm going to just copy this so I can go back if I want to. Go there. That's a copy of customer. And I'm going to make a copy of, staff. There's only 2. Copy of staff. Make a copy of staff. And I'm going to make a copy of store. And now I'm supposed to make a okay, I'm in store. Let's stay in store. I have to add a field called phone ID. So I'm going to add it at the end of the end. It's okay. All right, so I'm adding this this field here after the at the end. I'll just add it at the end. After last update, it's going to be called phone ID. Phone ID. It's going to be an integer, and it can be I guess it can be null. Yeah, because we're going to set it to null if it's so it can be null. It can be null, and that's all I got to do. Save it, and then I got to go to structure. All right, I got to go to relation view, and these are the other ones. I got to make a new one, add constraint. Oh, it already has place. It already has place for me. So it's going to be phone ID, and on delete it's going to be set to null, and on update it's going to cascade. And it's this database, same. And the table is phone ID. No, table is phone, and it's phone ID is the field. All right, that's it. Okay, I'm gonna copy this out. I'm gonna copy this. Make sure you do that. I'm gonna put it somewhere. Okay, so I'm going to set that aside. And that's store. Now I got to do the same thing for staff and customer. So let's go back here. I'm gonna take a quick peek to make sure that's there. Relation view. Yeah, it's there. Okay. I did save it. Okay, so I got to go to staff structure. Let me add phone ID after there. It's going to be called phone ID. ID is an integer. It can be null. That's all I got to do. And I wonder if I need to put that in here too. I'm just going to copy this out just in case. I don't think I think it's already added. And so let's go back to structure. Let's go to relation view, new constraint. It's going to be phone ID is Richard H. Sakila. It's going to be phone ID. On delete, set to null. On update, cascade. All right, save. And I'm going to copy this. And the last one is going to be, I got to do this for customer. I'm supposed to delete. No, I'm supposed to go into address and delete address. Remove phone column from the address table. Okay. All right. So first of all, let me add this phone ID. And it can be null. And I'm going to put a structure, relation view. I'm going to add a column, phone ID, same database, phone ID. Null if it's deleted, and cascade if it's updated. And let me copy this. I didn't copy that other thing, but that's I can recreate it if I need to. It's this, just that on the other three. And then I'm supposed to, let me go back here. And where's the address? I'm going to make a copy of this because I don't want to. Okay, so I'm going to call it, does this work? No. Underscore 2022-03-10. It's today's date. Copy it over there. And I'm supposed to go in. Really? I'm supposed to delete the phone column from the. Really? Okay. So let me do the structure. I'm supposed to delete the phone column. Oh, that is weird. Delete the phone column. Drop. If I really want to execute this, I'm going to copy this. Copy here. Okay. Yes, I do want to do that. Okay, it's dropped. And now, all right, I'm gonna get the create table for phone. So let's go back to here and go to phone. And I'm going to go to export. And I'm going to export custom. And I'm going to dump any rows. Don't need to do any of this stuff. I want to output as text. I'm just going to copy it. And whatever, go. And so this is what the create table looks like. And this sets the primary key. So let me copy this. Just do that. And let's go back here. And so this is that. So this is the create table. I don't think I need to, I'll just take off this default character set. I don't need any of this crap. And I can put this over here. And I want to do that one, and I want to do this one. And that's store and staff. Customer. And then I got to drop the phone from address. So really, so this is it. Let's see if this. So I'm going to see if this works. Copy. Paste. Yeah. Okay, the problem here is on line 11, it says this phone, this doesn't exist in the table. So that means I probably need to include these add ones. This adds phone ID to staff. And I need one for store, and I need one for, so let me copy store here, add to store, and I need to add to customer. That's easy. So I better throw these in there. Copy. So let me, I'm gonna put these right here. And this is where I start. Put a little marker there. So this is where I start. Let me copy this and see what this does. Copy. And I'm gonna place all this just because I want. Okay, so this is the new one. This thing increases in size. Now that's nice. So let's run this. What does this do? Okay, I'm going to submit it and see what happens. And it seems to have worked. 10 out of 10. All right, well, very good. So I did covered chapter 4 and I did 4.10. It's a little late, but thanks for watching.